Today we're going to take some review notes, and this is going to help us for our quiz coming up on Monday. The first thing that I want us to write down are some vocab words. Is there anyone who remembers what this would be? A comparison of two quantities. There's a way you can write it 3 to 4, 3 to 4, or 3 over 4. Halen, what would that be? Not a proportion. We have learned about that, but that's not it. What is it? Ratio. Very good. Everyone take your red pen and write down. That is a ratio. Let's go to the next one. This is a ratio of two quantities using different units. So you can see 16 miles in 4 hours. Does anyone remember what that would be called? Not a proportion. It is a rate. Let's go to the next one. This compares a quantity to 1 unit of another quantity. So in this case, 4 miles per 1 hour. Does anyone remember what that is? A unit rate. Very good. Now, something that's important about a unit rate, it tells us next that it will always have a denominator of 1. Write that in there with your red pen. On to the next one, two ratios that describe the same relationship. So this means 3 miles per 1 hour is the same thing as 6 miles per 2 hours. Does anyone remember what that's called? Equivalent rates. Okay, so that means that they are equal. It sounds to me like there's quite a few of you guys that should spend a decent amount of time making sure you know what these vocab words are before your quiz and test next week. Finally, the last one, we talked about this yesterday. Two ratios that are set equal to each other. What is that one? Proportion. There you go. Everyone's been trying to tell me that one all morning. Proportions is correct. All right, we're going to use this table below to write the ratio, find the value of the ratio, and interpret what that means. So we haven't done this for quite some time, but there are two things that I'm comparing here. So what you see over here is fruit punch ingredients, but right now I only want to compare two of them. I am comparing the sugar to the mint leaves. All right, so you don't really need to worry about anything else for this problem other than the sugar and the mint leaves. So let's focus on this. If you would, just put a little X or a star on the sugar. How much sugar does it say I need for this recipe, class? 1/2 cup, okay? So I am comparing 1/2 cup to, the other thing I'm comparing it to is the mint leaves. How much mint leaves do I need? 3/4 of a cup. This is how I chose to write the ratio, but if you remember, I've taught you a few different ways. You also could have written it as 1/2 with the word 2, 3/4. And finally, what's the last way we could have done it, class? 1/2 over 3/4. When I ask you to write a ratio, I do not care which way you write it, but you will not need to write all three. In order to find the value of the ratio, the key word is to divide. Very good. Now, you've got a little bit of space underneath where it says interpretation. So if you would, just write this down underneath there. We're going to take 1/2 and divide it by 3/4. Kaylin, what should I do next?
You gotta divide. Can I just say the answer?
Nope, how do I find this answer?
You have to keep change flip.
Very good. We're going to keep the first one, flip the second one, and change the operation. Kaylin, is there anything I can do to cross-reduce? Very good.
One turns into a 2 and the 2 turns into a 1.
Very good. And what's your answer?
2/3.
2/3. Excellent. So I'm going to put that up there where it says the value of the ratio. Remember, anytime you want to find the value of the ratio, all you're doing is taking the first quantity and dividing it by the second quantity. Now, we learned about interpreting what this means from the sugar to the mint leaves. Here's what I want you to write down. The amount of sugar is 2/3 the amount of what?
Mint leaves.
The amount of mint leaves. So all you're doing is you are taking the first thing, comparing it with the second thing, and telling me basically what the value of the ratio is. So the amount of sugar is 2/3 the amount of mint leaves. Okay, for this next one, it's the same idea. You'll see it's still the same fruit punch ingredients, but now I'm looking at two separate ingredients. Which ingredients am I comparing this time?
Club soda to lime juice.
Club soda to lime juice. Okay, so down here, I'm only focusing on those two. Zion, what is the ratio going to be?
4 to 4 over 3.
Very good, 4 to 4 over 3. And once again, I don't care how you write that ratio, with the word to or with the fraction bar. Now let's actually work this out. Adam, at the bottom, we are going to take 4, which I'll put it over a 1, divided by the second amount, which is 4/3. Adam, what should I do?
Drop down the 4 over 1 and change the sign, and it will be 3 over 4.
Very good. Can I cross-reduce anything?
Both of the 4's, which becomes 1,
Very good. And what's the answer?
3.
3. So the value of my ratio is 3. Is there anyone who would like to try to help me with how to interpret what in the world this means with the 3 versus the club soda and the lime juice? What do you think, Caleb? Look at how we did problem A.
The amount of club soda is 3 cups. 3 cups the amount of lime juice.
Okay, does that sound right? He said the amount of club soda is 3 cups the amount of lime juice.
3 times?
3 times the amount. There you go, Zion. Okay, so you need 3 times the amount of that. All right, so if you go back through when you're writing out your interpretation, if it doesn't make sense, try to figure out what is it that doesn't make sense about it, okay? So the correct answer is the amount of club soda is 3 times the amount of lime juice. Okay, so this one asks us to find the missing values in the ratio table and then write what the equivalent ratios would be. There are 3 different things that I have here, so everyone just put a little 1, 2, and 3. All right, there we go. So if I am working from the top to the bottom, do I divide or multiply? I am going to divide. If I'm working from the bottom to the top, what do I have to do? Multiply. Okay, so for this first one, I am going to try to figure out the value of the ratio by dividing that top number by the bottom number. 24 divided by 3/4. Kyla, tell me what to do.
So you're going to draw an arrow, then 24 over 1 divided by 3 over 4. And then flip the second and change the sign.
Can I cross-reduce anything?
Yes, you can cross cancel 24 and 3. 24, 8, and
Very good.
32.
Excellent. So that is the value of my ratio. Now, what did we learn about the other 2 spots once I found the value of the ratio for the first? They're all going to be the same. The value of the ratio is the same because we are making equivalent ratios. Let's go on to the second one. Brandon, how do I find, if I say that it's 8 miles, how many hours will it take me to drive that 8 miles? Am I working from top to bottom or from bottom to top? Very good. So when I work from the top to the bottom, should I divide or multiply? I am going to divide. So here I've got 8 over 32. Okay, 4. That doesn't make sense. If it said 32 over 8, 32 divided by 8 would be 4. But in this case, I just want to know, can you reduce 8 30-seconds? Is there a number that goes into 8 that also goes into 32?
4.
A 4 can, but there's actually something bigger than a 4.
8.
An 8. When you do that, what would this be reduced? Class? 1/4.
So it was just 4 in fraction form, but flip.
Zariana, help me with that last one. I know it's going to take me a half an hour, but I've got to figure out how many miles I'm traveling in that half hour. How would I do this? I am going to multiply because I am working from the bottom to the top. So 1/2 times 32, which means half of 32. Zariana, what's half of 32? Okay, it is 16. Now you could have also come down here and crossed this out, 1/16, and you would have found out no matter what, the answer is 16. Okay, so now we haven't done this part for a while, but equivalent ratios. At this point, I do not need the value of the ratio any longer. I am now just comparing miles per hour. So the first one says for 24 miles, it's going to take me 3/4 of an hour. Halen, what would I write for the second comparison?
8 and 1/4.
8 to 1/4. Heather, what would I write for the last one? 16 to 1/2. And those are my equivalent ratios. Okay, section number 3 says to find the unit rate. If you remember, we talked about unit rate has to have a denominator of 1, okay? So I'm going to take the first thing that I have there and divide it by the second thing. So 80 pounds to 5 months can also be written 80 pounds to 5 months. But remember, I don't want a denominator of 5. I want a denominator of 1. What number can I divide 5 by in order to turn it into a 1? Good job. We're just going to divide it by itself. If I divide the bottom by 5, I also need to divide the top by 5. Here's the next thing that's real important with unit rate. Make sure you give me the units. Okay, so Anson, what would this answer be? 16 pounds per,
5 minus 5 divided by 80.
okay, per 1 month. Very good. Let's go on to the next one, problem B. You ran 14 miles in 3.5 hours. The unit rate is saying, I don't want to know how much you ran in 3.5 hours. I want to know how much you ran in 1 hour. I'd like you guys to try problem B on your own. Lexi, how do I get this answer?
Divide by 3.5 on top and bottom.
Very good. And when you did it, Lexi, what did you get?
I got 4.
For what? Remember, you got to have units attached.
For the bottom one, I got 1 hour. For the top one, I got 4 miles.
Okay, so 4 miles in 1 hour. Okay, the next one, number 4, says, tell whether the rates are equivalent and show how to find the answer by using 2 different ways, the unit rate and the cross products. So here's what we have, 60 feet for every 5 years. Let's imagine that there's a little tree that's growing, and I tell you, it grows 60 feet every 5 years. And then I say there's another tree that grows 26 feet every 2 years. I want to see if they are growing at the same rate. So the first one, the unit rate, means I don't want to know how much they grow in 5 years. I want to know how much they grow in only 1 year. Gerard, how would I find that out? Very good. When you divide by 5 on the top and the bottom, Gerard, what do you get? 12 what per year? Okay, so the first one we found out, it's growing every year 12 feet. Zion, how do I figure out how much that next one is growing? Okay, very good. Listen, this should actually be a pretty simple one. If something's growing at 26 feet in 2 years, if I want to know how much it's growing in 1 year, what do I have to do to it? Divide it by 2, cut it in half, and what do you get? 13 feet per year. Zion, what do you think? Are those growing at an equivalent rate? Are those equal to each other?
Almost, but no.
Almost, but no. That's a fantastic answer. So the answer is definitely a no. Okay? Now, on your quiz, I do not care which way you find the answer, but I want to show you there's more than one way to find out if something is equivalent. You could also do it by using cross products. So for cross products, we're going to write it out kind of the same way. 60 feet every 5 years, and we're trying to figure out, is that equivalent to 26 feet every 2 years? As I said, we could use cross products to figure this out, which means I'm going to multiply this on one side, so 60 times 2, and find out if that is equivalent to this diagonally, which would be 26 times 5. Halen, what's 60 times 2?
120.
120. And Halen, what is 26 times 5?
130.
130. What do you think, class? Are those equivalent? No, because 120 does not equal 130. The answer is no. As I said just a minute ago, I do not care which way you find the answer, but I want to show you there's a couple different ways that can help you decide, are they equivalent or not? Okay, number 5 says to tell whether or not the quantities are proportional by determining if the value of the ratio is equivalent. So notice, we know how many cups I need, and we also know how many tablespoons I need. What I want to figure out is if this is correct or not. So I'm not going to take the value and put it all the way across. I've got to determine what the value is for each one. So if I am working from the top to the bottom, what should I do? Divide. For this first one right here, what will I have to divide?
15 divided by 3.
15 divided by 3. Guys, what's 15 divided by 3? 5. I'll put a little 5 up there. Now let's work on the second one. Aubrey, how do I find what the value of the ratio is for the second one? We're going to take the top number and divide the bottom number. So what is 65 divided by 13? 5. All right, so far this looks good, okay? What do you guys think the answer here is going to be? All right, many people would say 5, but let's just work it out to double check and make sure. This is why it's always real important to show your work. Number 3, how would I figure out what that value of the ratio is, class? Divide. Take the first one, which is 10. I'll say 10 over 1. And divide it by the second one, which is 1/2. Keep the first one. Flip the second one. Change the operation. What is the answer? 20. So, class, is this an equivalent table? No, they are not all 5, so the correct answer is no. That's why it's important. Don't just assume that you know what the answer is, but go through, work out the entire thing to make sure it makes sense. All right, for the next one, it says, tell whether or not the ratios form a proportion by using cross products. I'd like you to take your red pen and circle or put a cloud around this cross product. So you know that's what it is that I'm looking for this time, okay? So we'll take the first one, 6 to 4, and write it as 6 over 4. And 8 to 10. I'm going to see if it forms a proportion. Remember, a proportion is 2 ratios that equal each other, so I'm going to put equals 8 over 10. Circle the ones that are diagonal. Drop down that equal sign. On the left side, we're going to have 6 times 10. Anson, what should I put on the right side? Okay, don't say 8 in parentheses 4, 8 times 4. Okay, so we understand what those parentheses mean. Let's keep working down. Addison, what is 6 times 10? 60. Kaylin, what is 8 times 4? 32. Caleb, does that equal each other? No. If it doesn't equal each other, that means it does not form a proportion. Okay, we're going to go on to problem B, which is done the same way. Kaylin, help me out. What do I do?
We're on B, right?
Mm-hmm.
Yeah, okay. Don't you have to divide 1/2 by 1/4 first?
Good job. 1/2 divided by 1/4 is equal to, what should I put on the right side?
Oh, 16 over 8.
Very good. And we're using cross products, so what should I do?
Oh. times 8 and 16 times 1 fourth.
Very good. Okay, so drop down that equal sign. We're going to do a half times 8 and a fourth times 16. Keep going.
4 half times 8 is like 4.
Very good. Okay, you can cross reduce both of them. 1/2 of 8 is 4. And what's a fourth of 16?
Use your brain.
Very good. It is 4. Okay, so Kaylin, does 4 equal 4?
Yes.
Then yes, that means they do form a proportion. All right, let's look at the next one. It says to solve the proportion and tell which method you used. Mental math doesn't work every time, but I want us to see if it happens to work this time. So let's think about this. This was from our flipped classroom we had yesterday. We know the first fraction, so we are working toward the second fraction. On the bottom, do you guys know how I would get from a 7 to a 28? What's the missing link? Multiply by 4. Very good. So if I multiply by 4 on the bottom, what do I have to do to the top? Also multiply by 4. So let's focus on this. Guys, what's 5 times 4? 20. And then it asks us to tell which method we used. What method was that?
Mental math.
Mental math. That means you're doing most of the work in your mind. It is mental math. Mental math does not work every single time. When I'm looking at the next one, I am trying to figure out how I get from here to over here. Is there a clear missing link between a 12 and a 15?
No.
No, there is not. The other way I taught you was multiplication. But I did say you are not allowed to use multiplication if the x is in the denominator. So there's only one way that I can do this problem. What way would that be? Cross products. When doing cross products, we know that we want our x to be on the left side. So I'm going to start with this down here. Let's drop down the equal sign. A lot of people do x plus 1 times 12. Does that look like the normal way we would do it? No, we would normally have that single number in front. So instead, I'm going to switch this around and say 12 times x plus 1. Does that look like some problems we've done before? Yes, it does. Then I still have to multiply this part up here, 15 times 20. All right, so this is like what we learned in our lesson 5.4. This number is on the outside, so what do I have to do with that number, class? Distribute it. So I'm going to distribute it to this first one and to the second one. Girls, what is 12 times x? 12x. Plus, boys, what's 12 times 1? 12. Class, what is 15 times 20? 300. Very good. Now, this goes back to what we learned in our last chapter. We don't want to get rid of the 12x yet. Instead, we're going to get rid of that plus 12. What's the opposite of plus 12? Minus 12. So I'm going to subtract 12 on both sides. This cancels out, and I'm left with 12x equals, what's 300 minus 12? 288. Hey, Lynn, how do I get that x by itself?
You divide the 12 on both sides.
I am going to divide by 12 on both sides. When I do that, Lexi, what do I get?
X.
Very good. X equals 24. Class, did I use mental math, multiplication, or cross products to answer that? Cross products. So write somewhere there that we used cross products to find that answer. Okay, so for this next problem, it says you can type 50 characters in 2 minutes, and your friend can type 75 characters in 2.5 minutes. Do these rates form a proportion? So basically, are you doing your work at the same level? All right, so 50 characters in 2 minutes, is it equivalent to what your friend can do with 75 characters in 2.5 minutes? What's one way you think that I could figure this out? Cross products, okay? So I can multiply across from each other. On the left side, I've got 50 times 2.5. On the right side, I've got 75 times 2. We know that 50 times 2.5 is 125, and 75 times 2 is 150. Do those form a proportion? No, they are not equal to each other. Okay, if you guys would turn to the very back of your green paper, and I want you to write down question number 9 and 10. All right, so these are going to be important. I did not put them in your notes, but I did want to go through a couple examples because you are going to have some things that you see like this next week on your quiz and your test. The first one asks, are 2/3 and 5/9 equivalent? So you guys are going to actually write that question down. I don't want you just to do the work, but I want you to actually write the original problem down like you would on a homework problem, okay? So we're trying to figure out, are 2/3 and 5/9 equivalent? Do they equal each other? One way that we could do this is cross products. So I want you guys to do that on your own and see what you get. Okay, on the left side we've got 2 times 9. On the right side we have 3 times 5. Girls, what's 2 times 9? 18. Boys, what's 3 times 5? 15. Class, is that equivalent? No, so those ratios were not equivalent. Try the next one on your own. Okay, so a lot of people just did cross products, and cross products would work, but there's also another way we could answer this by doing mental math. Guys, if I'm trying to get from a 3 to a 4, what would my missing link be? 3 times what number equals 12? Sorry. 3 times what number equals 12? 4. So I could multiply by 4. Is this also a true statement? 8 times 4 equals 32. Yes, so that would help you to see you can use mental math, and that is correct. You also could have worked out with cross products, which is what quite a few, how many of you guys would say you did cross products? What was 3 times 32? 96. And what was 8 times 12?
96.
Okay, so either way, you could have figured out that yes, this is equivalent. All right? I hope that these notes are going to be a help to you for your quiz coming up on Monday.